Okay, so today we're going to go over matrix equations again. And what I've done for this one is I picked the three hardest problems that were on the matrix equations paper that you've received today. So let's go over one of the hardest ones. It's number 2. For number 2, normally when you have x times a number equals some other number, we would divide this and try to get rid of this thing right here. Unfortunately, matrices don't have division, so what we have to do is we have to do the inverse. So when we do the inverse of both sides, this should cancel with this, and then we would times the inverse on this one right here. Now if you noticed, I put it on the back side because if you multiply a matrix on the back side, you have to keep it the same because they don't have the commutative property, so you can't actually flip it. So first thing we're going to do is we're going to find the inverse of this matrix, which the inverse of this matrix is 1 over the determinant, and then we switch D and A, and we have the negative of the B and the negative C. So let's find the determinant. You find the determinant by multiplying the diagonals and subtracting them. When you do this, you'll get negative 18 minus 77. And then we want to flip these things, so I'd have negative 3 up here, 6 down here, and negative 7 here, and 11 here, or negative 11 here. Which this would become 1 over negative 95, negative 3, negative 7, negative 11, and 6. Now that's the inverse, so we would need to times it over here. So let's do that. And whatever we get should be our answer. I'm going to erase some of the stuff so that I can have some room to work. So this is 1 over negative 95. And the matrix that we had here was negative 3, 6, negative 7, and 11. Now we have to multiply this. You can leave the scaling for the end. So I'm going to divide. After I multiply everything, I will divide it by negative 95. But before that, let's do this multiplication. So you always go row by column, which that would be 47 times negative 3, so 47 times 3, so negative 141. And then we would go negative 56 times 11, so we'd have 56 times 11. Oh, that was a negative 11. So that was 56 times negative 11, which would give us positive 616. And then we're going to go, we're going to go this row by this column. So let's do those multiplications really quick. So we'd have 47 times 7, which would give us negative 329. And then negative 56 times 6, which give us negative 336. Now we have this row by this column, and then this row by this column, and then we'll be done. So we have 81 times 3, which will give us negative 243. We'll have 47 times 11, which would give us negative 517. We'll have 81 times 7, which would give us negative 567. And then we'll have 47 times 6, which would give us positive 282. So now I would take all of these numbers, add them together, and then divide by negative 95. So we'll just take 141, we want that to be negative, plus 16 divided by 95. That would give me negative 5. We'd need to do 329. That's negative minus 336 divided by 95. That would give me 7. And you can see that this is a long process, but most of this is just, once you get the inverse, it's not too bad to figure out these things. And the last one. Whoops, did I type something in wrong? I think I did. Whoa, one more time. Sorry guys, keep typing different things in wrong. There we go. That's what I was expecting to get. Okay, so as you can see on this process, the first thing that you should do is you should find the inverse, and we find the inverse of these things by taking one of the determinant, flipping the matrix and timesing them. Then you times the inverse on both sides, it'll cancel on the left. Then when you times it on the other side, you will see what matrix we will get, and that's what x would equal. This matrix right here. Let's try another one. Okay. Even though number 6 actually looks tricky, it's one of the easiest ones. We want to solve for c. So the first thing we would do is we're going to add this matrix right here to get rid of it on this side. And adding matrices are really easy, unlike multiplying, because you just add the like rows and terms. So we'll just add the like rows and terms, and we will get 4c is equal to, well, that's going to be 16, 4, -4, -8, 0, and 8. And then, now you can't divide matrices, but you can divide numbers. So just like kind of the determinant, we take all the numbers on the inside and divide by it. That's what we're going to do with this. So we'll just divide all the numbers by 4. That's 4, 1, -1, -2, 0, and 2. And this